Here is a question based on congruency. Let's discuss what the question is first and then I will explain it through the diagram. It said that QX and RX are the angle bisectors of the angle Q and angle R respectively. XS is perpendicular to QR, XT is perpendicular to PQ. This one are the angle bisectors. Now what we are supposed to prove here is XTQ, XSQ are congruent, as well as PX bisects this angle P. This has to be proved. Now to prove this, first we'll have to prove these two triangles are congruent. This is a hint for the next proof. Let's see. Proof. In triangle XTQ and triangle XSQ, what all are equal here? You check. If this is perpendicular, this part is also going to be perpendicular. I will mark it through a red right angle sign. These two are equal. We already know that QX is the angle bisector of this angle Q. Okay, hence this and these two should be equal angles. So angle. What about the other thing, the third corresponding side that we have to talk about? That is the common side, that is XQ is the common side. So by this, that is AAS criteria, we can prove that these two triangles are congruent. Now just let's check here. Angle XTQ is equal to angle XSQ is equal to 90 degrees given. Okay, and angle TQX equal to angle SQX, this is also given. Why? Because QX is a angle bisector. Now QX is equal to QX common side. Okay, therefore by AAS congruence criteria, triangle XTQ congruent to triangle XSQ. Now here where I have written here given and given, here 90 degrees given I wrote. Here you can say that QX bisect angle Q, like this also you can write. Okay, so this is what? This is the proof of these two triangles being congruent. Once these are congruent, we cannot directly touch these two sides. I'll show you. If at all we consider PXT and PXM, apart from 90 degrees or PX being common side, we don't have anything else there to compare as the third part which we have to show as equal. So for that, what we will do is we will consider these two triangles. Now before that, I would like to say here XT and XS will be equal. XT is equal to XS by CPCT. Fine, it is CPCT. How CPCT? You know that these two triangles are congruent, hence XT and XS are going to be equal. Now I'm going to erase this and consider the other two triangles. Which two triangles? Now I will be considering these two triangles. Now why should I consider these two triangles? When I consider these green marked triangles and I prove them congruent, what happens is XS and XM will become equal. I have already proved that XT and XS are equal. If I prove now XS is also equal to XM, now these two, that is XT and XM, will become equal. which will help me to prove the line PX bisects angle P. Let's see how we do it now. The congruency for these two triangles, the one which I have marked by green, is also going to be same as that of the first one. Just check it here. Here it is XRS or XSR, whatever you would like to. XRS and triangle XRM. XRS, XRM. Now see here, angle XSR is equal to angle XMR. Okay. Now there is a question, where did this M come from? Because it is not given and nothing is being said here. So before we write this, we can write a statement that construct XM perpendicular to PR. Okay, and then we can start writing this. Angle XSR is equal to angle XMR is equal to 90 degrees by construction. Then angle XRS is equal to angle XRM, because the reason is RX bisect angle R. It is also given actually, as I told you in the previous proof. Okay, now what is left? XR is equal to XR common side. Okay, therefore by AAS congruence criteria, triangle XRS congruent to triangle XRM. Okay, therefore what will happen here? XS, hope you can see, if you are not taking it down, XS is equal to XM CPCT. So the earlier one can be treated as 1 and this as 2. Hence, what will happen here? From 1 and 2, here XT is equal to XS is equal to XM. Okay, here we can take it as 3. So all three, this one, are equal. Now we will go ahead and prove that the triangle XTP and XMP are congruent. Hence those two angles will be equal, the one which we wanted now. Okay, so let me erase this. So this additional construction part has to be remembered, that XM is the perpendicular constructed to PR, which is not given in the question. Now okay, in triangle XTP and triangle XMP, now you can see that what is the criteria that you are getting. Right angle is there, these two sides are equal. We need one more side which is equal or congruent. Now XP, when I take, you may think, ma'am, side angle is not there. No, I'm not talking about side angle. I'm talking about RHS. Right angle is this. Opposite to right angle is the hypotenuse, that is PX, that will be equal for both or common hypotenuse, and these are the sides which are going to be equal. So first right angle. Angle XTP is equal to angle XMP is equal to 90 degrees. Given and construction. Given and construction. R, H now. H is what? PX is equal to PX common hypotenuse. Common hypotenuse. Then what we get? One of the side, that is XT is equal to XM by 3. Hope I am numbering it as right. Therefore, by RHS congruence criteria triangle XTP is congruent to triangle XMP. Well, therefore angle XPT is equal to angle XPM by CPCT, that is corresponding parts of congruent triangle. If these two are equal, then what will happen? Therefore PX bisect angle P. Okay, I'm showing you now, just watch it here. This is right, this is also right. The hypotenuse is at the center, so it is common hypotenuse. XT and XM are equal by what we have proved. These two and these two are congruent by that. So it is RHS. So now when these two are congruent, the angles over here, these two become the overlapping angles and they are equal. So PX is dividing the angle P into two equal parts. That's what we say it as bisect the angle P. Hope you have understood it thoroughly. This is again a congruency criteria question which has an additional construction, and it should be understood and done.